Comet 3I Atlas has captivated our attention ever since astronomers announced its arrival. Since its last close approach to Earth, it has traversed much of the solar system, raising many questions, and for a time the eyes of the world were upon it. What seemed like a simple interstellar object ended up behaving very differently from any known object. We found extraordinary radio signals, jets directed towards the sun that some scientists theorized could be artificial, an inexplicable color change, and with delays in some NASA images, many began to speculate about its possible extraterrestrial origin. Is Comet 3I Atlas a natural object, or is there something more to it? In this chapter, we'll explore everything we know and what we still don't understand about the discoveries surrounding Comet 3I Atlas and what its fate holds. Let's begin. Just a moment, guys. Only 13% of subscribers know when we publish new videos. Make sure you subscribe and turn on the notification bell, because without it, you'll miss formats and documentaries you won't find anywhere else. New data from 3I Atlas. When Comet 3I Atlas was first detected in 2023, it seemed like just another passing object in the sky, another rock in the pile, but its trajectory didn't match anything known. It came from outside the solar system. That made it the third confirmed interstellar object in our history after the famous Oumuamua in 2017 and Comet 2I Borisov in 2019. However, 3I Atlas proved even more intriguing than its predecessors. Unlike Oumuamua, which had an elongated shape and never showed cometary activity, and Borisov, which did release gas and dust like a typical comet, 3I Atlas seemed to combine the best, or the strangest, of both. Its hyperbolic orbit clearly indicated that it wasn't from the solar system, and its passage became a unique opportunity to observe a visitor from another star up close. But we had to act quickly. Its entry speed, exceeding 100,000 miles per hour, meant it could only be within range of our observational tools and instruments for a short time. What was most striking was how close it came to one of our planetary neighbors. On October 3, 2025, 3I Atlas passed within a mere 28 million kilometers of Mars. In cosmic terms, that's a considerable distance, but enough to observe it in detail from that planet. Thanks to this close approach, a coordinated campaign of observations was launched by space agencies worldwide. NASA prepared the Mars Reconnaissance Orbiter to capture images of the comet, while the ESA deployed its instruments on Mars Express and ExoMars. Even the MAVEN probe, specialized in studying the Martian atmosphere, pointed its sensors toward the interstellar object. For several days, all the spacecraft positioned at Mars were pointed in a single direction, Comet 3I Atlas. Even the Perseverance rover on the surface of the red planet pointed its camera at the sky. And although it may seem insignificant, this was the first time humanity had managed to capture images of an interstellar object from the surface of another planet. The interesting thing is that the images astronomers were most eager to obtain were those that would reveal the comet's nucleus, and therefore its proper shape and size. However, NASA delayed publication of these images by 3 weeks. The delay ignited a fury of speculation. Various theories about hidden findings, confidential information, or a possible extraterrestrial origin began circulating on social media. But the real reasons for the delay were more straightforward. The official reason for the delay was the temporary closure of certain U.S. government offices and NASA departments, which slowed data processing and publication. But when the images were finally released, they weren't what astronomers had expected. A blurry image, but enough to shed some light on the comet's nature. It helped complement images from the Hubble Space Telescope, allowing scientists to estimate the comet's diameter, which could range from 0.32 to 5.6 kilometers. This makes it larger than Comet Oumuamua and therefore brighter. Just after its close approach to Mars, Comet 3I Atlas would begin its perihelion, reaching its closest point to the Sun. This event caused a stir in the astronomical community, as many astronomers believed that after its close approach, the comet would simply disintegrate. Therefore, if we wanted to study it, it had to be before that happened. According to orbital predictions, in March 2026, 3i Atlas will pass relatively close to the most massive planet in the solar system. This not only represents a unique opportunity to observe how an interstellar object interacts with Jupiter's gravitational environment, but also allows scientists to study the effects of gravity on its trajectory and internal structure. In other words, we could see if the comet behaves like one in our solar system, or if it still holds surprises beneath its surface. And there's a perfect mission for this task: the Juno spacecraft. Since 2016, Juno has been orbiting Jupiter, studying its atmosphere, magnetic field, and system of moons. Although its primary objective wasn't to observe comets, its instruments have proven to be highly versatile. It has already captured transient events that no other observatory has documented. NASA plans to use Juno to observe 3i Atlas closely during its approach. Although the pass won't be as close as its encounter with Mars, it will be within the probe's field of view, which could provide unprecedented data. But Juno won't be alone. Ground-based telescopes such as the James Webb Space Telescope and likely other missions such as Lucy, as well as observatories in the Planetary Defense Network, could collaborate to monitor the comet's behavior from multiple angles. Will it remain active beyond the orbit of Mars? Will its trajectory change after passing through Jupiter's influence? Will it fragment? These are all open questions, and each one has the potential to change what we know about interstellar bodies. 3i Atlas may not be an extraterrestrial spacecraft, but it is an interstellar visitor that has left its mark on humanity's historical record. It is a comet that has traveled for billions of years in the intergalactic medium, from another star until it crossed paths with ours. But 3i Atlas is just the latest chapter in a story that began years ago. Before this mysterious visitor appeared, two other interstellar objects shook the foundation of astronomy and sparked debates that continue to this day. The first was Oumuamua, an object so strange that some scientists seriously considered whether it could be artificial. Its bizarre elongated shape, its unexplained acceleration away from the sun, and its complete absence of cometary activity made it unlike anything we'd ever seen. Then came 2I Borisov, which seemed almost disappointingly normal at first, until scientists realized that its normalcy was the anomaly. How could a comet from another star system look and behave almost exactly like our own? Now that we've seen what 3i Atlas has revealed, it's time to go back to where the story truly began. Because to understand these interstellar visitors, we need to examine all the evidence, all the mysteries, and all the questions that Oumuamua and Borisov left behind. Let's rewind to 2017, when everything changed.